analogy for thinking through this stuff in machine learning is the professor analogy. You already know all this stuff because you've taken exams, and if you've ever set exams, even better. So let's have a quick look. You're the professor, and your student is going to take a calculus exam tomorrow morning. So the student has written, luckily, something down from the board to study from. There we go, an equation. I said no equations, and look at me lying. So the entire job of the student, the machine learning system, is to go from the inputs, the left-hand side, to the outputs, the right-hand side, correctly. And so this is what the student's going to learn from, going to learn really, really hard, and find a pattern that works. You can just turn the 8 on its side, and there you go. And I want to point out that in these data, where the student is learning, training, it works. This is correct. 100% accuracy. Now, at this point, would you go to the exam if you were the student? I mean, I've certainly taught some undergraduates who I think would have gone to the exam. I've had to grade their papers and cry a little. But you, my dear enlightened audience, you wouldn't just go to the exam based on this, right? What would you do? What do I hear? Try another one, exactly. But there's an important difference between you and my student. My student also tries another one. They try it on the exam, where it matters. Whereas you have the wisdom to try it in the safety and comfort of your dorm room, check your understanding while you can still go back and adjust your model if you don't get it. So what you are doing and they're not doing is validation. That is what validation in machine learning is all about. A safe environment to try it out, where you're still allowed to go back because the stakes are not high here. A soft interim test. So let's try another one. Apply our model. We get performance, and turns out that's not how math works. And based on this signal, we then can ask ourselves, fine, should we go to the exam or should we go back to training? Then the student sits there and tries out all these extra practice problems that you, the professor, have given to them. And finally, at 3 o'clock in the morning, you, the professor, get an email from the student. Validation passes. I did all of the practice problems correctly and all of the in-class examples correctly. Please give me my A+. I don't need to go to the exam because I've done it. And your response is? Of course not. Now why? Why do you say that? You say that because your student could have contorted their understanding to the in-class examples and the validation examples and just memorized the whole lot. Maybe even without realizing that they'd memorized them. Just formed some recipe, some model that fits what they've studied. That doesn't generalize to anything else because it's just some crazy mishmash of the peculiarities of those examples that they worked with. And you don't know if that's what they did because you know they were allowed to retry both the in-class problems and the practice problems many times as they want. You don't know what kind of mad logic is going to come out of that. Memorization is possible there. And so you, as a wise professor, are going to say, absolutely not. I'm so glad for you, student, that you feel like you've gotten yourself to a state where you're confident, that things look good for you. But to really make sure that I don't release any really bad students out onto the world, you should come to the exam and we'll check that you know it. Now, professors, you already know the requirements for the final exam questions. What has to be true about them? The most important thing. The student is not allowed to have seen them before. Because if the student has seen them before and knows the answer to them, the student could be memorizing. And your entire goal as a professor in this machine learning space is to make it so that your system cannot win by memorization. It cannot just do the look up the old answers insofar as I remember them, and submit that as my new answer. And the only way you catch memorization is if you give truly new stuff for the testing. And that's why we have that separate test phase.